All right. Hello, everybody. Welcome to another physics video lecture. Today, we are going to be looking at something very specific that is very important. And honestly, it really highlights one of the most amazing tricks that we can do using graphs. All right. Here's the question. How can I find displacement from a velocity graph? Okay, so in the past, it was really easy to find displacement from a position graph, right? It shows you literally the distance, okay? You just go up and down, you see how far somebody moves, and that's that. But with a velocity graph, we don't know where they started position-wise. This graph doesn't tell us how far somebody's moved, okay? So what we're gonna do here is we are gonna employ one of the coolest tricks that there is when it comes to graphs, okay? In order to do this trick, you got to check a couple of things. Number one, the question has to be asking for displacement, okay? That's number one, okay? How far did somebody go? Number two, it has to be a velocity time graph, meaning on the y-axis, you have to have velocity, okay? This doesn't work if it's a distance time graph or an acceleration time graph. It has to be velocity, okay? So here's the trick, right? We know that velocity equals distance divided by time, right? Okay, so if I want distance by itself, okay, well, I have to move time, okay? This is division. The opposite of division, as you know, is multiplication, and we always multiply by the number on the bottom of the fraction. So whatever I do to this side, I multiply by t. This side, I multiply by t. T divided by t is 1, and this gives me distance is equal to velocity times time. So if I want to find the distance, I got to figure out what is velocity times time. Well, look at this. Here, I have velocity on the y-axis, and I have time on the x-axis. If I multiply my y-axis by my x-axis, what I get is the area of this graph. I'm going to let that sink in. To find the distance, what we have to find is what is this area? Because look, v is this length, right? And t is this length. If I can find this area underneath, that is my distance. That is velocity times time. It's the definition of area, okay? Pretty amazing, right? So let me show you how this works. This is why it works, and let me show you how to do it. And we'll look at a few examples. Okay. First step. We got to remember how to find the area of two shapes, and we're only going to use two shapes, okay? We're going to use rectangles, and we are going to use triangles, okay? All of these shapes that we're going to look at, we're going to break them into rectangles and triangles. I'll show you how to do that in a second. So the area under a velocity time graph is displacement. We just saw why. To find the area of a rectangle, this is easy. All you do is you take the height and multiply it by the base, right? Remember, this was our y-axis, this is our x-axis. The base times the height, that gives me area. And again, this is distance, or sorry, this is velocity, and this is time. Distance equals velocity times time, which is your height times your base times height, okay? A triangle, you do the same thing, but a triangle is actually just half of a rectangle. So you do the exact same thing with a triangle. You do base times height, and then you divide all of it by 2. And that's how you find the area of a triangle, or okay, at least a right triangle here. Actually, with any triangle. Isn't that beautiful? So we only have 2 equations. Base times height for rectangles, 1/2 base times height for triangles. Please write this down. Draw yourself a picture. These are very useful. Okay, So let's see this in practice. How do we do this? Okay, so I want to find the displacement of the curve. Step number one, break your area under, we call this a curve just because it's easier to say. I know it's not curved right here, but that's okay. But you find the area under the curve by breaking it into triangles and rectangles. And make this as easy as you can. I'm going to draw my line. Wow, that is pretty off. Let's see if I can do that again. A little bit better. I'm going to draw my line right there. Okay, so now what I have is I have one rectangle and one triangle. Okay, this rectangle happens to be a square, that's fine, it's still a rectangle. Now I need to find the base and the height of both of them. Okay, the base is right here. Okay, so the base of my rectangle is obviously going from 0 to 2. That's 2. And my height here goes from 0 to 4. That's 4. Okay? So to find the area of this right here, okay, we'll call this 1, we'll call this 2. To find the area of 1, it equals the base times the height, which is equal to the base 2 times the height 4. So the area here is equal to 8. Boom. Easy, right? For number 2, let's look at our base. Our base goes from 2 to 4, okay? And remember, if you ever want to find this, you always take final minus initial. So 4 minus 2 is 2. And hopefully you see that, right? If this goes to 2 to 3 is 1, 3 to 4 is 2. And our height is still the same, right? Our height goes all the way up to here, which is still 4. So now, to find the area of 2, we use 1/2 base times height, right? And so what we're going to do is always do the base times height first. So this is going to be equal to 1/2 2 times 4. 2 is my base, 4 is my height. 2 times 4 is 8, and 8 divided by 2 is equal to 4. Now all you got to do is just add them up. This one was 8, this one's 4, that makes sense, right? It's half of this. 8 plus 4 is equal to 12. And we're trying to find the distance, so this is always going to be in meters. And it's just that easy. This is one of my favorite tricks, okay? If you have a velocity graph, all you got to do is find the area of some triangles and rectangles and add them up. All right, let's do another one. Let's do one that's a little bit more difficult. Okay, so here, we already drew our lines. We got A, B, and C. This is a velocity versus time graph. So I just got to find the area here to find the displacement, okay? So here we go. We'll do A first. Let's do this. So let's figure out what our base is. Okay, so the base of A goes from here to here. 0 to 10, our base is 10, and our height, from there to there, 0 to 20, is 20, okay? So for A, we're gonna have base times height divided by 2. This is exactly the same as this, so don't let that confuse you. I know I used this one the first time. This one might be a little easier to see, but these two things are 100% equal in terms of math. 1/2 base times height, or base times height divided by 2. Same. We plug our numbers in. Our base is 10. Our height is 20 divided by 2. 10 times 20 is 200 divided by 2. 200 divided by 2 gives me 100 meters. So A is 100. Check. Done. All right. Next, let's do B. Okay, B, we go from 10 to 30. 30 minus 10 is 20. And our height is still the same. It's still 20. So for B, this is just a regular old rectangle. So it's just base times height. Our base and height, again, are 20. And our height is 20. And 20 times 20 gives me 400 meters. Pretty easy, right? Last but not least, C. C is obviously a triangle, so we're going to use base times height divided by 2. Okay? And we go from 30 all the way to 70. Okay, so 70 minus 30 is 40. That's our base. If you wanted to count that regularly, you would see 10, 20, 30, 40. Okay? But I like to do final minus initial. I think it's easier. Times our height. Here's our height. Boom, still 20. Divided by 2. 40 times 20 is 800. And 800 divided by 2 is 400. All of these are meters. So now we have A, B, I forgot to put the C. Let's make it look like the other ones. I like consistency. All right there. If I wanted to know, if the question asked me, how far did the object travel in total, I would do 100 plus 400 plus 400, which would give me, sorry, this is rattling. 100 plus 400 plus 400 gives me 900 meters. So my total distance is 900 meters. But it might ask you a different question. It might say, how far did the object travel between 10 and 30 seconds? Well, all you would do then is just take those lines and draw them. Go 10 seconds up, 30 seconds up, and just find this shape, which in this case is B. So from 10 to 30 seconds, the object went 400 meters. Okay? And you could do this for any shape. It could say between 30 and 50 seconds. You would draw a line there and there. And now you would split it into these two triangles. Okay? You have a triangle and a rectangle. And you would find the area of this piece and the area of this piece and add them together. So it doesn't matter what time they're asking for, you just need to break this down. All right, so let me take a second. That's a lot. All right, it's pretty good. Okay. So just to kind of show you what I'm talking about, if the question ever asks between time, let's say I just want to know from 30 to 50 seconds. 30 seconds to 50 seconds. What is the displacement? Okay, what I would do is I would draw my line here, up, and from 50 seconds up, and then I'm going to make triangles and rectangles. And the easiest way to do that is to go like this, right? The base of my triangle here goes from 30 to 50, which is 20 meters. The height here, from there to there, goes from 30 to 10. So this is 10 meters. Okay? And then I do base times height, which would be equal to 20 times 10. Again, this is for my rectangle. Okay? 20 times 10 is equal to 200. Now for my triangle, this is something people look at. This is my height right here, right? And my height goes from 10 to 20. 20 minus 10 is 10. So for my triangle, I have base times height divided by 2. My base of my triangle is still 20, but my height is now 10, right? Divide that by 2. This is 200 divided by 2, which is equal to 100. You add these together. 200 plus 100 obviously equals 300 meters. So between 30 and 50 seconds, I went 300 meters. It's just that easy. Okay? You just got to break it up into these little shapes. And just remember this two very easy equations. A rectangle is base times height, and a triangle is half that. All right. So let's do one more big example to see one last little bit of nuance here. red's a little harder to erase. Good. All right, let's do one more hard example. All right. So now we have positive and negative. So first step, break this into pieces. This is going to be a lot of pieces. Here's our first piece. I'm going to use red. That's our first triangle. This is our second piece. That's a rectangle. This piece right here, this is our third piece right there. Okay? Now we go down to the bottom. Now we have this is our triangle, and we're going to have this as a triangle. So we're going to take that. Pause the video. See if you can figure out what the total displacement is from start to finish here. You got a number? Let's see how you did. We're going to call these A, B, C, D, and E. We have 5 pieces and we're going to solve all of them. Okay, so for A is a triangle, which means base times height divided by 2. Okay, my base here goes from 0 to 10, so that means this piece here is 10. So my base here is 10 times my height right there. My height is obviously, goes all the way up to here. So my height is 60. Divide that by 2. Okay, this gives me 600 divided by 2. And again, I like to do all my pieces individually. 600 divided by 2 is 300, and that's meters. That's A. B. B is a rectangle. So B is easy. B is just base times height. Okay, circle this. My base goes from here to here, which goes from 10 to 15. 10 to 15 is 5. So my base is 5, and my height is 60. Very good. So here I have my base times my height. 5 times 60 is equal to 300 meters. All right. Here's one. Okay. Let me go over here. For C, actually, yeah, I can do it over here. Actually, I'll do it up here. For C is a triangle, obviously, so that's base times height divided by 2. My base here goes from 15 all the way to 30. From 15 to 30, 30 minus 15 gives me a base of 15. Right? Each one of these looks like it's 5. So 5, 10, 15. Perfect. Times my height, which is still 60. And we're going to divide that by 2. Okay. Mental math, Mr. Norris. 15, so this is 300 plus 900 divided by 2, and 900 divided by 2 is equal to 450 meters. This equals that. Boom. Okay? Let me double check my math. I'm doing that in my head. That seems pretty sound then. All right. 2 more. We got D. D is another triangle, so that's base times height divided by 2. Okay, let's look at the base here. The base here goes from 30 to 40. 40 minus 30 obviously equals 10. And now my height here, ooh, look at that. My height goes down, 0 to negative 40. So my height here is actually negative 40. Oh ho ho, divided by 2. 10 times 40, or negative 40, equals negative 400 divided by 2, which is negative 200 meters. Ooh, interesting. It's the bottom, it's negative. E, our last one, that's D. Also a triangle. So E equals base times height divided by 2. Let me move this over here so you can see it. Okay, our base here goes from 40 to 55. 55, right, because this is 50, so this is 55. 55 minus 40 gives me a base of 15 times our height. And again, our height here goes all the way down to negative 40, going from 0 down. divided by 2. 15 times negative 40 would be 600. So this is going to equal to negative 600 divided by 2, which will equal to negative 300. All right? Beautiful. Okay, so if we want to take all of this together, okay, right, where we're going up, we're going down. Now, if we want to find the total distance that we traveled, first up, distance is never, ever going to be negative, right? So if we want to find our total distance that we traveled, we would just add all these up. So 300, so distance, let me do this in blue. We're doing it on time. Okay, almost done. So distance is going to equal to 300 plus 300 plus 450 plus 200. Remember, I don't care that it's negative. This is distance we're talking about. Plus 300. Ooh, that's a lot. Okay, so 300, 300, 600, 600, and 450 is 1050, 1250, 1550 meters. That's our total distance. If you want to know displacement, well, displacement can be negative. So it's the exact same, except we're going to add the negative. So now it's positive 300 plus positive 300 plus positive 450 minus 200 minus 300. So it'd be the same thing, 1050, but then minus 500 would be 550 meters. Okay? There's one. So there's your distance and displacement. Distance is all positive, displacement can be negative. And you do the exact same thing. If you want to know any specific unit of time, whatever it says, how far did you go between 10 meters or 10 seconds and 15 seconds? Well, you'd find this shape right here. Between 10 and 15 seconds, he went positive 300 meters. How far did he go between 30 seconds and 40 seconds? Well, that's this shape right here. At D, he went backwards 200 meters. Okay? Find the area, and you will find the displacement. So all you got to remember, it's got to be a velocity graph. You got to be looking for displacement or distance. And you got to remember that triangles are base times height divided by 2, and rectangles are just, where's a rectangle? Base times height. All right, guys, good job. You're going to crush this. Find me if you got questions.